All right, let's get started. So welcome here to Privacy Pass at IETF 124. One of the co-chairs, Joe Salloway, and we also have Ben Schwartz on the line. There's Ben. I'm going to ask folks as part of the meeting process, it's good to not have your video on until you're ready to talk. And the same thing with audio, just to kind of keep because there's not much room on the screens. The other thing I'll ask folks to do is if you're in the room, please sign in with your in meeting on-site tool. So that way you can join the queue. That's how we'll run the meeting in terms of participation. And then also that's how we know how many people were at the meeting and how big of a room to request next time. So let me move forward here. And you're probably familiar with the note well. I just will say a little blurb about this. And it's a reminder about the processes and policies of the IETF, including about conduct, privacy, intellectual property rights. These are things that you agreed to follow when you sign up to participate in this meeting. So you should read this carefully, and you're encouraged to go follow the links to the supporting documentation, which is referred to in this note well. And if you have questions, you can ask the chairs, you can ask your ADs, and we'd be happy to help you. So we do have a bit of, let's see, I think I already covered things here. Also, when you're talking at the microphone, it's great to speak your name for note takers, both the automatic note takers and the human note takers. We do have a packed agenda today. So I'll run through a quick overview of the document slides, and then we have some discussion of anonymous rate limited credentials, anonymous credit tokens, and then some discussion on the kind of the similarities and how these things support each other. And then we also have a little bit of informing the working group of what's going on with MOC and PRIVACYPASS. I might have the wrong person presenting there. Apologies if I do. Are there any agenda bashes that people want to do at this particular point in time? Great. We already have a scribe. And so we will go on to talk a little bit about document status. We have a couple of documents that have completed working group last call. We have document shepherds assigned to all three of them, but we have some non-chair shepherds. Thank you, Watson, for taking on the PrivacyPass issuance protocols and public metadata, and Julia for the private token HTTP authentication. We are waiting on author responses to help them finish the document shepherd. So if you know these folks who are the authors, I've talked to a couple of them, so hopefully we'll get responses to that. For Bash token issuance protocol, one of the chairs right now is assigned shepherd to that, but there are still some comments from the working group last call that I believe need to be addressed. We have two recently adopted drafts on anonymous rate limited credentials and the kind of cryptography behind that. And then we do have some expired drafts in this working group that we will need to figure out what to do with, whether these are still important items or you know, how we move these forward. Ben, do you have any other comments on the document status?
No, I don't think there are. I don't think I have additional comments.
Okay, great. All right, then we can move on to the first presentation, which I think.
Sorry, I have a quick question.
Yeah, please.
Robert from the batch tokens draft. So I think we addressed all comments.
Okay.
Yeah, I don't think it's on. Is it on?
It's
Okay, now
on, yeah.
better.
It's just
Sorry.
you have to be real close.
Yeah, I think we addressed all comments, so we should be ready for the next step, which
Okay,
I think is
I'll-
ISG.
Perfect. I'll take a look and it's my missing that. So I'll take a quick look and then we can move it forward.
Okay, thanks.
Yeah. All right. So I believe for the agenda, let's see. So Kathy, I'll give you. Except you need to have the right set of slides, huh? Sorry.
That would be nice.
Yeah.
Awesome. That looks like
You
it.
should have control as well.
Perfect. Yes. Awesome. Hi, everyone. Kathy. I'll talk about anonymous rate limited credentials, which we must just call ARC. And that is the combination of these two specs. One is for the issuance PrivacyPass issuance protocol, which is PrivacyPass ARC, and one is for the crypto parts, which is now PrivacyPass crypto ARC. Chris and I have talked about this in the last 2 IETF meetings, so hopefully this is something the group is familiar with at this point, but I will do a little bit of a refresher, as I know it's been a few months. Very high level, this is the PrivacyPass issuance workflow from RFC 9576, and the salient point that I'm trying to draw from this is that you basically request one token, and then you present one token, and there's this one-to-one relationship, and it's very simple and it works, but what we would like to propose as sort of a modification of this workflow is something that is a little bit more general and allows for more general anonymous credentials workflow. So this would support ARC, it would support ACT, it would support hopefully a large variety of other kinds of like more complex credentials. So the critical thing, the critical modification here is that instead of requesting and getting issued a token, you instead request and get issued a credential. And this credential you hold on to locally, and you can think of it as like a longer lived credential that can be presented multiple times. And the way that you present this, the mechanisms are a little bit different between ARC and ACT, but the general intuition is that the credential is something that you hold on to for a little bit longer than you would think of normally a token in the previous workflow. So in the ARC setting, we're sort of pitching ARC as a better approach to rate limited tokens. It did seem like there was a lot of interest in having some kind of way to do rate limiting with PrivacyPass with previous drafts, but it was not very clear the best way to do this. There's a lot of like infrastructural overhead, and we think that this is sort of a better approach because it allows you to do per client rate limiting, sort of baked in because each credential inherently in the ARC credential setting has a rate limit for that credential. Like you can only present the credential up to a certain number of times per epoch per origin. But then I also think that we go above and beyond that, where you have a few more benefits, where you have the property that like you can create many tokens from just one issuance, as I mentioned. So if you have an issuance protocol that's really cumbersome, maybe it's just it requires user interaction, or it's like really high overhead, or really computationally difficult to issue, you can just make one issuance for a credential and have that credential work for rate limiting over a long amount of time. And even in addition to that, there is this really neat sort of function where you can have sort of more complex rate limiting policies on that credential. And the folks from Cloudflare coined this in their latest blog post as like late origin binding, which is basically you can get the credential, and then at the time of presentation, you can present that credential to different origins, and different origins can have different rate limiting policies. And so you can say, I want to rate limit to allow like 100 presentations for origin A, but 10 presentations for origin B. And additionally, you can also have more fine-grained rate limiting per epoch. So you can say, I want 10 per hour, and you can have that be a policy that's valid for many hours, many days, or even weeks. And you can have that be, again, origin dependent. So I think there's a lot of flexibility here. And for the settings where I think the rate limit tokens were appealing, I think these sort of policies or this flexibility is also very useful. Awesome. So that's just a little recap of what ARC is. And we have a lot of updates since our last meeting. We went through call for adoption, as Joe mentioned. We have a lot of progress with nonce hiding, and we have some updates from the ZKFE space. Awesome. So we had a call for adoption for the PRIVACYPASS issuance protocol and what we originally were calling the CFRG spec, which is basically the crypto parts. The CFRG spec, it's interesting. We basically had an agreement between PRIVACYPASS and CFRG chairs that we could adopt that, basically do a call for adoption in PRIVACYPASS as long as we solicit a crypto panel review prior to WGLC. And so that was the plan we went forward with, and both of them are now adopted. So thanks to everyone who was supportive and showed a lot of enthusiasm and buy-in for adopting these drafts. And there are both B drafts for the PRIVACYPASS working group going forward. So I will rename those. This was just last week, so I haven't gotten a chance to rename the specs yet. But yeah, looking forward to continue working on this within the working group. Awesome. Second is nonce hiding. So as a refresher, last IETF, we sort of posed a question to the group of, hey, in our current design, we send the nonce, which is use once value for rate limiting. We send it in the clear with the presentation. And that results in some interesting, weird privacy properties where if you have the same nonce but different tags, you can actually be certain that those nonces came from different credentials, and that gives us weird privacy properties. And we asked the group, is this acceptable? Sometimes, depending on your deployment constraints, it may be okay. And the group was sort of pretty much unanimously no, let's fix this. Let's hide the nonce. So we took that into account, and we actually have a pretty good solution where we will hide the nonce by making a commitment to it, but then have a range proof to prove in zero knowledge that the nonce is between 0 and the rate limit. The easy way to do this would be with a power of 2 range proof that we all know and love, where you basically just do a bit decomposition of the hidden value and then prove that each bit is 0 or 1. And if that is true and you recompose the bits into the hidden value, then it has to be in range. So that's fine and could work, but then you have this weird engineering level, deployment level constraint where your rate limits can only be a power of 2. And that's a really weird constraint to push up to your adopters. And so we actually asked the community, what can we do about this, and found that you can actually do a range proof over an arbitrary rate limit by making more careful choices of the bases that you decompose your values to. So this is actually quite elegant and allows us to have an arbitrary rate limit without significant overhead, either computational or complexity overhead. Another nice thing that we sort of got from the community is that originally we thought we had to use an OR statement to prove that each bit is 0 or 1. We could do this, but it results in higher complexity from the zero knowledge proof compiler to support OR statements. And instead we got suggestions on how to use instead 2 AND statements to prove that the bit is 0 or 1. And that allows us to make a lot of simplifying assumptions for the zero knowledge proof compiler, which is really nice. And so with all of these tricks combined, we have a really nice solution to hiding the nonce, and we're basically working on that now. I will say the caveat is that we have released some benchmarks, but all of the benchmarks, because those were done sort of in parallel with this exploration, did not have the range proofs. So adding the range proof will change the performance a little bit. It'll increase the presentation creation and verification, but hopefully not too much because it only scales logarithmically with the rate limit. But I'm gonna call that out as a caveat. So yeah, the status is that the specification is complete. We have this written up as a part of the spec, but we're working on the reference implementation right now. So that hopefully we'll have to show next time we meet. And as a note, this is actually useful not just for ARC, but a lot of other specs as well. For instance, in CFRG, yesterday Chris Patton was mentioning how this would be useful as a way to generalize the FLP proofs, and I'm sure it'd be useful in many other places as well. So it's really useful, reusable work. And I do want to call out that it was really great working with the community on all of these problems. I think it was a really good showcase of a lot of smart, helpful, collaborative people coming together and making all of these things work and coming up with good solutions. So yeah, thank you to the folks listed here and others as well for basically contributing and giving lots of good ideas and tips. So yeah, always great group of people. Also, the last point is zero knowledge proofs. We have a lot of good progress here. Biggest thing is CFRG adopted what I call the zero knowledge proof building block specs, which is the interactive Sigma protocol spec and the Fiat-Shamir transform spec. So basically, the interactive Sigma protocols are interactive. The Fiat-Shamir transform turns those interactive proofs into a non-interactive proof. And so we sort of use those together. And with this, ARC can basically move to use these specs, and we can get rid of the entirety of section 5.1, the Schnorr compiler, which is what we've been planning to do all along, but we wanted to wait for a little bit more stability and adoption of the building blocks. So ARC has modified the spec to use the building blocks, but hasn't updated the implementation yet, and so we want to wait until the implementation is also in line to push all of these changes to the main spec together, but that's something that we're actively working on. I do want to call out that one interesting choice for the Sigma and Fiat-Shamir building blocks is that the implementation uses an opinionated EC group implementation. Michele will talk more about this in CFRG tomorrow, but what that means is that I think it's the right way to go, but it is a little bit more adoption overhead because we have to switch our EC group implementation over to the underlying implementation so that they're compatible. But very, very addressable, just a little bit of a delay. But I do think overall, stepping back, this is huge for the community because like these building blocks are useful for obviously ARC, for ACT, for potentially like VDAF proofs just across the entire like cryptography spec space. And so it'd be really great to have this as a reusable piece so that not everyone has to like hand wire their ZKP circuits. So I'm really excited about this. Awesome. Next steps. I think especially as we're seeing more PRIVACYPASS token types come out, ARC, ACT, we're in very, very early stage development for Atom, anonymous tokens with hidden metadata. I'm sure as people keep exploring this space, like we will keep seeing new interesting use cases and token types. I think it's really worth understanding like where in the like token space, usage space, do each of these lie? Like when is one useful versus another? I think Thibaut is going to start talk about this with ARC and Atom in his talk, but I think generally as a group we need to get a better understanding of like when does it make sense to use what tokens. Another next step, mostly from our spec side, is to do the reference implementation with nonce hiding and move over to use the Fiat-Shamir and Sigma specs. This is something I'll be working on the next few months and also welcome contributions from the community, especially now that the spec is adopted by the working group. Yeah, very happy to have more working group input here. And then lastly, I don't think that this is in scope for this particular spec, but I do think we as a group should investigate post-quantum or everlasting anonymity schemes for the anonymous credentials that we're looking at, just because this is something that is pretty important. And yeah, so that's what I have for next steps. I think in conclusion, like the progress over the last few months since IETF 123 has been huge, and it's been really, really awesome working with people from the community on both like enthusiasm getting this adopted, on making better range proofs that are reusable, making sort of changes or building blocks for zero knowledge proofs. And I think a lot of this is like really great work that's good, not just for the spec, but just for the broader community, and really great to really good to see. So thanks everyone for all the good work. Cool. I'm open to questions.
Any questions? Sam?
I was just wondering how you guys are mitigating the post-quantum risk. In particular, is there like guidance in the draft that says like you must delete these or you can't log these, stuff like that? Or is that something you'd be interested in adding?
Currently, well, I guess to give background for other folks, we have post-quantum unlinkability between the issuance and the presentation. And so you can never, even with the quantum computer link back to the identity of the user, but we have linkability between multiple presentations under a quantum attacker. In this setting, we are looking at different constructions for the rate limiting tag, but they all have like a lot of overhead or complexity, and so we haven't settled on anything that we're really happy with yet. But to Sam's point, we don't have any guidance on how you should handle the tags like deleting or clearing. To address that, I'm happy to add that. I just don't feel like it's super robust, but maybe it's better than having nothing. So yeah, happy to work on that.
Thanks.
Any, Ben?
Hi, thanks for the update. I noticed the analysis in relation here. So I think that's I'm really glad to see that you're thinking about how to explain the relationships there. Cloudflare's recent blog post on this topic included a bunch of benchmarks that showed that, you know, sort of apples, but by my reading, in an apples to apples comparison of total server side costs, that Arc is coming in about 4 times the CPU cost of batch PRF. So I'm wondering, what is, where do you think that is going? Do you think, you know, there's a lot of optimization room there? Do you think that we are, that Arc is going to be really useful in cases where issuance happens very often, but redemption is rare? You know, what's the use case where the balance tips?
Yeah, that's a super great question. I think that's exactly what I'm trying to get at with like, we need this analysis. I think my intuition is that Arc is more useful when your issuance is like really costly. Like if issuance requires like a human interaction or some kind of like authentication authorization, like that's a pretty heavy lift, and you really want to reduce the number of issuances you have to do. In a way where, like, if you're doing batch PRFs, maybe you run out of your batch and you have to request more, or you have to issue like a really, really huge batch to be, you know, to give you the absolute upper bound of the rate limit. So I think that's one example. I think another example, like what you said, is if you expect to issue one credential and maybe you want this credential to be redeemable across like many, many origins, across many epochs, but you don't actually expect the user to use all of those. You just want to give them the optionality. In the batch PRF setting, you'd have to like issue all of those and then give the user the option, or make the user sort of request each time they need something for a specific origin or specific epoch. So those are the settings, but I do think we like need a better understanding of this, because you are right, the verification overhead for Arc is much higher in relation to like VOPRFs and RSA blind signatures.
Thanks. That sounds very interesting.
Yep, Thibaut, Cloudflare. Do you agree? This is like exactly like the question I think we've been asking. Small precision on the blog and the data that Cloudflare has published. I don't think it's like directly a one-on-one comparison, because like Arc provides much more features which would be different use cases, and we need to explore exactly where it's a matching. And I'm very happy to see that like we need to see like the relationship between these types of tokens.
Okay. Thank you. I think we'll move on to the next presentation. So I think that's Sam. Sorry, I got a bunch of clicks to go through here, and then anonymous credit tokens. And then I will give you control.
Thank you. Is this working? Yeah. Okay. Hello, here today to present anonymous credit tokens. In particular, we discussed it last time at a high level, thinking about more of the cryptographic primitive. And here we're going to talk about the integration with PrivacyPass and how that looks, which we have a draft out now for. So for the updates as a whole, we've published the PrivacyPass integration draft. And we've got partial progress in porting the crypto draft to use the Sigma protocol and Fiat Shamir drafts. And then Chrome and Firefox are exploring how technology like this could be used on the web, and Cloudflare and Google are exploring deployment to rate limit AI agents, to be clear, separately in both cases. The motivation is really like important here because, like we just said, the performance is really different. So why not ARC, VOPRF, or blind RSA? So it's really 3 properties that we like. Concurrency control, we can only use 1 request simultaneously per credit token. Dynamic revocation, so it could be revoked by the issuer by refusing to refund the token. And then per session rate limiting, so you can have distinct rate limits to different users depending on whatever features of them you want to look at without impacting privacy. So you can adopt this in a lot more variety of cases. And just to remind everyone what this looks like, ACTs have a sort of a state machine in them. You start with a credential with N credits, and then you can prove a spend, which is like creating a presentation in ARC, but here you nullify the initial token. And then once you've spent it, you are waiting for the refund, and you have to reconstruct the token. And then you get the refund back, and then you construct the refund token, and now you have a new credential with N credits or N minus whatever credits. So that's pretty much just saying what I said again, but the key is that the original credential is now invalid, and it really must not be used again. And these credential chains are like the long-lived credential in this case. So to show, so there's a typo here that I missed. I just realized that the slides I just updated aren't these, but basically the protocol looks very similar to PRIVACYPASS architecture as it is. The only difference is that we now send back a response very similar to reverse flow PRIVACYPASS. And in the rest of the slides, credential request and credential response will be called token request and token response. So the first thing we do is we create an issuance request, which has these secrets that we hold on the client, and then the request that we'll send to the server. And then the client creates a token request structure that has this sort of form that you might be used to by now. And then this is actually sort of wrong. This request context should have gone into the issue request, but everything else is how it should be. And the server will issue a response, which will contain the credits that the user will get, and it sends that back to the server. Actually, I should briefly pause here. So in discussions throughout the months intervening, we've talked about different aspects of these protocols. And in particular, we've thought that we might need to keep a request context element in the credential itself. The sort of justification we came to in some discussions was we need to do this so that the issuer can dynamically set it. But this is actually like a privacy problem, and it turns out to be not the right thing at all. And so we don't need an extra field, and that should be something maybe people talk about afterwards or in questions. Okay. So then when you have a token already, you can create a spend proof, and the spend proof is essentially your presentation. So this is like your PRIVACYPASS token, and you create the token structure that we've got down there from this. And like I said, you can only make 1 token from any given specific credential, and you invalidate the previous one after. And then what I again left out of the slides, apologies, is that you then reconstruct, or sorry, words are hard, sorry. When you get the token, when you give the token to the server, and then you receive back a response, you now have to reconstruct the new token. And so you have this credential chain where you prove a spend, you get back the response, and then you reconstruct the next token. So you have these chains of credentials that cannot be used concurrently. And then here, this is the right place for the request context, where you are verifying and refunding the token. And then after this is actually where you would reconstruct the token. Okay, so next steps are porting the remaining bespoke Sigma protocols and Fiat-Shamir implementation to the CFRG standards, adding request context either in a field or as some hash to curve thing. And then there's a bunch of other issues that people can go look at. And yeah, I'm ready for questions.
Any questions? Chris. And
Sam,
Chris?
cool stuff. I'm wondering if you thought about the use case of like implementing block listing using ACTs, wherein you spend a token and the refund you get back is 0, like because you're potentially doing bad behavior, and that like essentially validates the credential. Maybe I tuned out when you already mentioned it, but like, is that something you've considered?
Yeah, so there's sort of a couple different ways to imagine doing some sort of blocking or some sort of abuse feedback. One is that you can sort of detract value from the credit token over time, maybe getting to 0. Another is that you can just refuse to reissue the token. And so I think the latter is like this hard hammer that you can hit on traffic that you think for some other reason might be malicious. And then the first one is sort of a softer thing that you can accumulate reporting of abuse over time.
Do you talk about these trade-offs in the draft at all at this point?
Yes.
Okay.
Yeah.
I should probably read the draft. Great.
Yeah, Chris.
Hello, Chris Patton, Cloudflare. What was I going to ask? Something really important. Oh,
Maybe a request context?
yes. Okay, so the privacy issue around request context, is you're thinking that like on reissuance in the reverse flow, the server might reset the request context, like the value of it?
It's more like the client needs to know the request context anyway, so that it can confirm that it's getting a token that doesn't uniquely identify it. So there's no value to the server dynamically setting it unless it has some way out of band to communicate it to the client. And so in Arc, they actually just do it where they put the request context here. So it goes into the token request.
Got it. Yeah, I mean, I think I totally agree. Like, no matter what, no matter how we implement the request context binding, it should be impossible for the server to reset it on reissuance, because that's just defeats the purpose. So.
Yeah, you could imagine a world where you might want to reset it, like you sort of like move someone into a new epoch or something like that. But yeah. Kathy?
Yeah, especially like as we're sort of exploring like how you can plug and play different functionality, and since we're in the early stages of developing something with like anonymous tokens with hidden metadata, I'm wondering like where in terms of like priority and feasibility do you feel like ACT has for that kind of block listing, but in a way that's hidden from the user? Like, is this something that you think is important that you want to integrate, or is it sort of like, no, we can do that with other token types, or no, it's just not high priority?
Yeah, so we've explored this a little bit. Nothing incredibly satisfactory. So what I'll basically say is that there are situations where this might be helpful for deployments, but it is not clear that such a satisfactory direct integration would be what we want to do.
All right, thank you. We'll give, yes. Should be okay now.
Okay, can you also give control to Lena, or I will pass? It's a co-presentation. I do with Lena.
Okay,
Okay, I will just say it.
Yep.
Okay. Hi everyone. So I'm doing this presentation with Lena Heimberger, which is remote. So I will do like the first set of slides, and then she will continue in the details. So I think a few presentation, as was mentioned, of what is referenced as the reverse flow. That's something which was presented at the IETF about a year ago, something like that. And that's something which we re-explored with like in the face of like anonymous credentials. And yeah, we will be discussing how we're thinking at the moment and explored to compose tokens. So this diagram, you more or less have seen variants of it through this meeting. It's the original PRIVACYPASS architecture, has an origin, has a client, has an attester, has an issuer. When the client accesses an origin and is challenged, it does an attestation with like the attester, and this can be like really varied in the form. Then it requests a token, gets a token response, finalizes the token locally, and then send the request again with that token. There are a couple of things which are important to note here. We're talking about tokens. We're not talking about credentials. And I think that's one of the modifications that happened in the previous diagram. And one thing in the original architecture diagram, you don't have token finalization, which is like highlighted. It's important to state that like the response given by the issuer is actually finalized into the token that will be presented. And that's part of what guarantees the unlinkability between issuance and redemption. There are a couple of limitations with this design that like the anonymous credential scheme that we've seen try to address. There's some issuance communication. The number of redemption is proportional to the number of issuance, and more than proportional. It's actually like linked one-to-one. In order to do redemption, I need to have an issuance. There's no way around it. There's some issue that like ARC tried like to address with like late binding. When you do a number of presentation and you don't know exactly what that number of presentation is, setting an upper limit to say, I want to get 1,000 token from the issuer might just be not the right way. It's like not very efficient because you will issue a lot of token and not all of them might be spent. And so late origin binding, which means at the time I actually need to present a token, I can generate it and bind it to an origin. It's like a very compelling story. And finally, you have one thing, which is revocation. Once access is given by the issuer, there's no way to revoke it. And this goes back to like late origin binding. When I issue for performance consideration 1,000 token, and I do see after a few like requests that like are coming that it seems that it doesn't work, I don't have a way to revoke this token. And because we have a big anonymity set, this is very tricky to do. We don't want to break that. At the same time, from an operational perspective, it doesn't seem to satisfy all the requirements we want for the protocol to have. So that's where reverse flow came in. This diagram is basically you take the privacy pass, the existing architecture, you just deploy it twice. And it's called reverse flow because when you have the flow, which is on the right, which is the flow that you make a request, get a challenge from the, to have like a token issued, you do an attestation, go to the issuer with your token request, get a response, finalize it. When you go to the origin, in this case, the origin has an issuer of its own. And this is exactly the same flow that you would have on the right side of the screen. It's the same flow, but reversed. Therefore, it's called a reverse flow. When the client sends the request to the origin, it sends the request, the token, plus a token request to get a new token from the origin. The origin, based on like its own attestation, or if it wants the client to continue making requests, it will reissue a token, send it back. And the idea is instead that you cannot do that when you have two requests, because otherwise you would link the two requests and bring the unlinkability property. When you do that directly as part of the request with the initial token, you're able to like keep that context and get the token back so the client can keep on making requests. This is a flow which is very similar to like what ACT does, for instance, with the reverse flow, but it's more general in a way that you can apply it to token request, to credential, and it's more an architecture presentation than a specific protocol or token specification. At Cloudflare, we've used that to compose existing anonymous credential schemes that have been presented, and I will let Lena present that. And Lena, if you need to switch slides, happy to do so.
I can give her control.
Thanks.
Okay.
Okay, thanks. So we've just to quickly recap on the two advantages that each of the tokens has. So ARC is great for parallel use and it supports late origin binding, which we've discussed, but it also has sublinear communication. But we can't revoke it. And ACT, we can revoke by refusing to reissue. We can also have a stateful policy, like if we don't like your request, we just deduct a bunch of your balance instead of only a little, but we can only redeem it sequentially. So moving on. Next slide, please. Oh, I can. Oh, sorry, I can do it. That's great. Sorry, thanks. So how do we add anonymous credentials to PrivacyPass? Our general idea is to replace the tokens with credentials, and also like in the reverse flow, we're going to do it twice. So in this diagram, we actually do assume that the issuer and the origin issuer are the same entity. And now I'm going to explain how exactly we're going to use the credential requests with ARC and ACT. So we want stateful, per origin, and revocable tokens. And at first, we start with an ARC token with a presentation limit of 1, which gives us kind of an anonymous identity. Then we present our ARC token at the origin, and the origin validates it, and then in exchange, gives us a stateful ACT with some credit on it, like 100 credits. And then we can continue talking to the origin using our ACT token, where we can basically revoke by just refusing to reissue a token or reissuing with a balance of 0. So another diagram to show how exactly this would work. The client sends the request with the ARC presentation. That could also send like the ACT token and then a request for a refund, and then you can perform your checks depending on what exactly you want to check. So you could you welded ACT, ARC, and also potentially some other rate limit. And the reverse proxy forwards the request to the origin, gets a response, and then the reverse proxy returns the response and the refreshed request. How do we imagine this to be used? So there are a number of use cases. We could use this for web application firewalls, to rate limit websites, media over quick, which I think we'll talk about in the next presentation. We could also use it for anti-fraud, and we could also use it to rate limit agents behind agentic origins, which is what we looked at originally. Yeah, and I think, yeah, that's it from me. Thanks, let's discuss this.
Any question?
Hello, Tommy Polly Apple. Thank you both for the presentation. Less of a direct question and more like just a comment on the value of this. I think this is very useful to talk about somewhere and write down and help people for the different possible deployment models and way to compose things. This is a pattern I've started to see emerge, and like besides reverse flow, it's something that I've also called like the refund model. And some of those models are different than all the use cases you have, but still there's a value in like how do you have these different privacy passes interact with each other. And so I think this is good. I think we should do the work. It's not, as you point out, a new token type. It's not a new protocol. It's more of a like extension to the architecture document. But I think it is a useful extension because it is a pattern that I've seen happening, and it's just easier to reason about if we have the good terms for it and the ideas of when this is useful and when it is not. So I appreciate the work and would like to see it continue.
I'm Suhas. I'm coming from the mock working group, and where we recently adopted PRIVACYPASS as one of the token authorization schemes. And working with Thibaut, we realized that having something like this is very useful in a mock setup where we have a CDN which authorizes resources, and we need to have this reverse flow to exchange token for every API access that you do to the CDN resources. Something like this we would like to see continue further, and how it can help in general for the mock deployments as well. Thanks for the work.
Okay, seems the queue is empty. So Colleen, I think that's your presentation.
All right, thank you. Calling you up.
Thanks. I'm Colin Jennings. It's my first opportunity to get to present in this working group. And what I wanted to, we were just in a second ago, they were talking about this media over quick work. What I wanted to touch on for a second was just a little bit about what this is and how we hoped PRIVACYPASS might solve some of our problems. This is very early work. We've just started a draft. Thibaut's kindly agreed to help us and join in on really making this fast. Thank you very much, Tommy, for some great comments. Sit back on this. I'm not really going to dig into the draft right now because I don't think what's in the draft is actually very important. I think just sort of a little bit describing our problem a little bit so you understand that, and then people can help us get to the right draft is the best thing. So with that, Media over Quick is a pub subsystem, and we really started this as a way to meet the needs of taking video conferencing systems like Zoom and WebEx and making their scale much larger. Right now, they don't scale up anywhere near as large as live streaming events. So that was one group that was interested. The other group was the people who were doing live streaming things like YouTube Live, Twitch, these types of events, who are interested in dramatically reducing their latency from what they're getting with CDN dashes today. So that's the background context of it. The basic architecture of it that's certainly relevant for the security stuff is it's a pub subsystem, and we have a bunch of clients. In these case, there might be some browsers that are watching some YouTube Live content, and they subscribe up to nodes that would often be run in a CDN network in much the same place that HTTP CDN servers would sit, and they we call them relays, but they think of them very much as a subscription aggregation device. So they're taking several subscriptions in, and they are somehow managing to get the publisher content coming from YouTube Live to one of these relays, and they fan it out to a bunch of clients. So that's the basic sort of architecture that we're trying to hit there. And there's a lot of other ones. It might be, WebEx clients is doing a live call, but they all have roughly this form of there's something going, there's relays that are aggregating subscriptions, and there's publishers that are publishing data that gets fanned out to all of those subscriptions. Now, in cases like this, the relays primary concern is that the publisher, they probably have a business relationship with the publisher and want the publisher to pay them. So they need to know they're going to get paid for this type of stuff. And often there's more things on it too. Sometimes there's geolocation of regions they're allowed to do certain things and other things. So it does get more complicated, but the very basic level it is that. And the clients, I see I still have the old version of my slides. I'm sorry for that. I'll fix the spelling on clients. The clients, though, do not necessarily, we do not need to reveal to the CDNs all the information about who the clients are or all the privacy issues that you might normally expect when you have a bunch of clients talking up to a cloud aggregation. So the clients have the relationship primarily with the publisher, and they want to not reveal all of that information to the relays, and the relays want to get paid. The scope of the authorizations is what's delivered in mock is tracks is the way we organize things. And tracks there might be one track for the audio, there might be one track for the video, there might be a bunch of tracks for the video that are different resolutions, there might be a bunch of tracks for the audio that are different languages, for example. But one way or another, there's a handful of tracks that they're trying to subscribe to. They do a subscription to this. And those could be very long-lived. When we're talking about security cameras or things like that, some of these things could go on for days, months, years. Some of the other ones, it's very limited the time over which an authorization will be valid. For the very long ones, we'd want to have a way to sort of periodically refresh and check that things hadn't disappeared. All of those types of issues, you can guess what those would look like. So when we started looking around, it looked like PrivacyPass was a pretty good match for this. I think so far in our initial poking at it, it has been, and there's, you start to realize things like the previous presentation where you can bring in much more complex issues to these flows as well. We're not, I think that hits the architecture and the key points. What can I tell you about the requirements or other parts of this that are useful for this working group? Step to. Okay, so I think that what I would say of sort of going forward on this, actually, there's a couple, sorry, I see there's a couple people I didn't see in the queue.
Yep.
Ben.
I think it might be helpful to have a distinction between whether we are, whether this is an access control to data or whether this is a access control to a service.
Yeah, so the mock, okay, that's a great question. The mock data model is very much came out of, ICN type thinking about this. So we very much view this as access to data. And the data is like a track is a unique name effectively for, think of a track having like a URL. It has a track namespace and a track name, but it has a unique set of things that's like, global unique, at least on that CDN identifier for the track as a whole. Inside of that, the track's broken into groups, and inside of groups are objects. And we're really, protecting access to those objects, I think, when we really get down to the heart of this.
Okay. The reason I ask is because access control to the data can be accomplished by cryptography. I mean, you can encrypt the data and give the clients the keys. But access control to the distribution service can't be controlled that way, because an unauthorized person could download all of the ciphertext, and that, I guess, would potentially violate your security goal. So yeah, I think we want to be clear about that.
Okay, I should say, add a little bit more on the wrinkle layer here, Ed, if we're okay to time. Yeah, so look, the data is primarily end-to-end encrypted outside of this in many cases. For example, of these cases, it might not be encrypted, but it could very well be DRM protected in an end-to-end type way. In the WebEx, like in a conferencing case, it's very likely to be end-to-end encrypted with MLS keying set up between the endpoints totally outside of this. So really what the use case here is, and maybe I answered the question wrong in saying, try and explain the data, but it's like what we're the fundamental thing here that we're doing is that the relays in the CDN are going to get paid by the publisher is really the heart of what we're trying to make sure is okay. Right?
Yeah.
In this use case, yeah.
It sounds like there's an interesting situation here where the attacker in this situation cannot access the data. The data is encrypted separately under its own key. And the attack here really is about somebody downloading a bunch of garbage just to run up the costs, even though they can't actually do anything with the garbage.
Yes.
Okay, thank you.
Cool.
Tommy
Polly, Apple. Yeah, that was good clarification. So thank you for getting that. Yeah, so I had sent some of the comments that are like, I guess, more technically focused on the details of the protocol. So, let's have that discussion on the list. But I guess maybe to try to up level from those, like, to your point, like what are like the higher level questions about the use case that I think would help answer these. So there's this aspect of the, like, are the tokens cacheable? Are they requiring like an online challenge or not? So I guess that's maybe more of a question, not about the requirements of the use case, but the requirements of the protocol and like how mock is set up. So is this something where you have like an online handshake exchange where it's okay to take kind of like a round trip to validate this? Or is this something where, for, let's say, efficiency reasons, it's very important to be able to have this be, more or less like zero round trip, or like to be able to have previously grabbed authorization that you then just spend quickly? Because those are two kind of common patterns, that it's like a trade-off of what you can guarantee versus the efficiency.
Right. And part of that might be like, we don't 100% know, and that's negotiable. But I would say that certainly not having a round. So some constraints that regularly come up is people really want to be, I mean, as any CDN at scale, they want to be able to validate these tokens without going back to a central service or something. They need to be locally validatable in some way. It seems to be a pretty common requirement.
Yeah,
or desirable property.
Right.
Yeah.
And I think the local validation, like that should be fine.
Okay.
Assuming you have your right key distribution, et cetera. I guess it's more like from the thing that wants to validate the token compared to the client that's trying to access the content. Is this something where there can be a back and forth there, or there already is a back and forth, or
there is not there is a there's a subscribe, and you could challenge it with like, I mean, it's modeled very after HTTP in many ways, right? Okay, so certainly
does it work like HTTP off?
Yeah, yes, it could, no problem,
okay.
Right? Okay. So we could go back and forth with relative round trips like that, but there's a real concern about initial setup time. So from the time you get going to the first time you see video on your screen, there's a real desire to minimize this. This is about latency. So I think that would be a strongly desirable property to have a zero RTT type solution in that, but certainly a multiple is possible. And there's definitely things in visions where, like, we can upload a token, we can send a token up from the client up to the server once, and then sort of cache it in a compression way, and we can refresh it over time, and we can reuse an alias to it instead of sending in every request. There's a bunch of mechanisms in the protocol to support those types of things.
Right.
I don't know if we really have a concrete worked out story on how we ought to do this as a practical way. Yeah.
Okay, that's good. And I think the other thing, and we don't need to answer it all here, but like I think getting to what Ben was asking, but maybe I could put it a different way, is like, what is the requirement around the granularity of the token? Because like if we want it to be 0RTT, that implies that it's something that we could like pre-fetch or pre-cache, which means that it's easier to do that if it's a larger granularity and not specific to every little bit of data. And so like, is that okay for it to be broader, just to say, yes, this is a legit client who has access to your service. They are someone who should have the keys to see this thing. Or does it really need to be super tied to, I'm validating you can access this one piece of content, in which case maybe it's harder to avoid the handshake?
Yeah, I think that's, architecturally, there's a bunch of people that are imagining a given client on a WebEx conference would have a token that accessed that conference, but not other conferences, for example. Or if I was watching a YouTube video that had several tracks or a YouTube live event, I might have a token that allowed me to access that bundle of tracks. Now, I imagine that if we went and sat with the group, there'd be people like, oh, I have a crazy use case that's finer grain, and I'm sure there'll be use cases that's just like, you have a token that says you can use the CDN network for the WebEx content. Have a good day, right? Like, so I think it's sort of in that range. It is not in the range of every single iframe every single frame of video, which is a different object in our groups, we're going to get a new token for every single object we fetch. Not like that at all. I haven't seen any use cases like that. So, yep. Thank you. Sorry.
Antonio Vicente, Cloudflare. I also have a question related to requirements. Do you see needing private tokens that are actually blinded in some way to actually authenticate things without really like tying the client to the data in some way? Like does the issuer actually have a need to actually like not know who the client actually is going to be in the future? Or are you actually willing to actually use a more standard signature style that's actually cheaper and doesn't actually have the same privacy guarantees you actually get from a blinded token?
I think the later on knowing I'm not sure I understand the question well enough to really answer that. I shouldn't say too much on that, I guess. Maybe.
Yeah. So if
closer to the mic, is it?
Sorry. So one thing I would like that some of the tokens that like are being used by this group is that they actually use some crypto to actually somewhat hide the identity of the person requesting the token in the first place, and being able to actually like redeem it in a way that like it doesn't really tie it to that, preserving privacy.
Right.
I would think that like for a access control of this sort, being able to actually like say, okay, I'm going to actually like tell it when issuing a signed token to actually access the content, you're actually willing to fully authenticate yourself there and like tie that token to you in some strong way.
I think they would keep that information for abuse. I'm imagining that they would have kept that information for abuse ways, but I would not think it would be bound to you in a strong way that was recoverable from the token, right? I don't know that that's a requirement.
Okay. I might talk to you offline afterwards.
Okay. And look, this may be very much in the area too of the working group has not thought about, the mock working group has not thought about the things it should be thinking about in this design, right? Like that's where I assume we are on some of this stuff. So it'd be really awesome to be able to talk about. Thank you. So look, we haven't discovered, it's just as next steps or whatever, we're going to keep working on this. It's not like we've discovered anything that caused us to think we needed, changes in this working group or whatever. What we do need is the expertise in this working group and the expertise in mock to figure out how we apply this technology and check it actually works like we're hoping. So appreciate the help on that. Thank you.
Cool. Thank you for bringing that here. Appreciate it. I think that's all we have on our agenda for the day. And so thank you for coming to Privacy Pass. Enjoy Montreal, and we'll see you on the list. And for the people at home, we'll see you on the list as well. Ben, anything to add?
Nope, nothing for me. Thanks for everyone for great presentations.